Robots are made to perform useful tasks. Each one is designed to solve a specific problem in a specific way. This robot solves the problem of safely driving a tractor through a field by moving towards the destination and making small detours if any obstacles get in the way. This robot solves the problem of getting through this maze by moving in timed segments. Let's take a closer look at this last robot. How does it do that? How does it know how to do that? Creating a successful robot takes a team effort between humans and machines. The human is responsible for identifying the task, planning out a solution, and then explaining to the robot what it needs to do to reach the goal. The machine is responsible for following the instructions it is given and thereby carrying out the plan. Because humans and machines don't normally speak the same language, a special language must be used to translate the necessary instructions from human to robot. There are many such languages, with Robot C being one of them. These human to robot languages are called programming languages, and instructions written in them are called programs. The human who writes the program is called the programmer. The programmer's job, therefore, is to identify the problem that the robot must solve, to create a plan to solve it, and to write that plan in a program that the robot will be able to understand. The program is loaded onto the robot, and then the robot runs the program and accomplishes the task it was given. Finally, take note. The robot only follows the program. It does not think for itself. Just as it can be no stronger than it is built, the robot can be no smarter than the program that the human programmer gave it. You, as programmer, will be responsible for planning and describing to the robot exactly what it needs to accomplish its task. Behaviors are a very convenient way to talk about what the robot is doing and what it must do. Moving forward, stopping, turning, looking for an obstacle, these are all behaviors. Some behaviors are big. Solve the maze. Some behaviors are small. Turn on your left motor. As you will see in this video, big behaviors are actually made up of smaller ones. As you begin the task of programming, you should also begin thinking about your robot's actions in terms of behaviors. Now recall, as a programmer, your primary responsibilities are, first, to formulate a plan for the robot to reach the goal, and then to translate that plan into a program that the robot can follow. The plan will simply be the sequence of behaviors that the robot needs to follow, and the program will just be those behaviors translated into the programming language. To find a solution, start by examining the problem. Try to see what the robot needs to do at a high level to accomplish the goal. Having the robot follow this path, for example, would solve the problem. All right, you've just identified the first behavior you need. Write it down. Now, start by trying to break that behavior down into smaller parts. Following this path involves moving forward here, then turning, then moving forward again, turning the other way, and so on. Each one of these smaller actions is also a behavior. Write them down as well, taking care to keep them in the correct sequence. Break those down again, and you'll reach commands that you can express directly in the programming language. For example, Robot C has a command to turn on one motor. When you reach a behavior that says turn on one motor, you can stop breaking it down because it's now ready to translate. When all the pieces have reached this level of detail, take a look at the list you've made. These behaviors, in the order and way you've specified them, represent the plan that the robot needs to follow in order to accomplish the goal. Because these steps are still written in English, or if you prefer a diagram, they should still be relatively easy to understand for the human programmer. As the programmer becomes more experienced, the organization of behaviors in English will start to include important techniques from the programming language itself, like if-else statements and loops. This hybrid language, halfway between English and the programming language, is called pseudocode and is an important tool in helping to keep larger programs understandable. By starting with a very large solution behavior and breaking it down into smaller sub-behaviors, you have a logical way to figure out what the robot needs to do in order to accomplish its task. By recording the behaviors in English, you have taken the first step towards good pseudocode practice, allowing you to easily review the behaviors and their organization as you prepare to translate them into program code. The only step remaining is to translate your behaviors from English pseudocode to Robot C programming language. Robot C is a text-based programming language based on the standard C programming language. Commands to the robot are written as text on the screen, processed by the Robot C compiler into the machine language file, and then loaded onto the robot where they can be run. Text written as part of the program is called code. You can type code just like normal text, but you must keep in mind that capitalization is important to the computer. Replacing a lowercase letter with a capital letter, or a capital letter with a lowercase, will cause the robot to become confused. Note that as you type, Robot C will try to help you out by coloring words it recognizes. If a word highlights in a different color, it means Robot C knows it as an important word in the programming language. And now, we will look at some of the important parts of the program code itself. The most basic kind of statement in Robot C simply gives a command to the robot. This statement inside the sample program you downloaded is a simple command. It instructs the motor plugged into port 3 to turn on at full power. The next piece of code, wait1msec3000, is also a simple command statement. It directs the robot to wait for 3000 milliseconds. Statements are run in order as quickly as the robot is able to reach them. Running this program on the robot turns the motor on, then waits for 3000 milliseconds, 3 seconds, with the motor still running, and then ends. The first statement ran, then the second, and when the second one ran, the robot simply waited for 3 seconds with the motor still running. 3 seconds later, the program tried to go on to the next statement and found that there wasn't one, so the program ended. Now, let's look at the way the two statements were written. How did Robot C know that these were two separate commands anyway? Was it because they appeared on two different lines? No. Spaces and line breaks in Robot C are only used to separate words from other multi-word commands. Spaces, tabs, and lines don't affect the way a program is interpreted by the machine. So why are they on separate lines? For the programmer. Remember that programming languages are designed for humans and machines to communicate. Using spaces, tabs, and lines helps the human programmer to read the code more easily. Making good use of spacing in your program is a very good habit for your own sake. But what about Robot C? How did it know where one statement ended and the other began? It knew because of the semicolon at the end of each line. Every statement ends with a semicolon. It's like the period at the end of a sentence. End of statement 1, end of statement 2. So, to review, statements are commands to the robot. Each statement ends in a semicolon so that Robot C can identify it, but each is also written on its own line to make it easier for humans to read. Statements are run in reading order, left to right, top to bottom, and each statement is run as soon as the previous one is complete. When there are no more statements, the program will end. You may have noticed that Robot C code tends to use a lot more punctuation than English. The semicolons used to mark the end of statements were one example, but most Robot C punctuation comes in pairs. Punctuation pairs, like the parentheses and the square brackets in these two statements, are used to mark off special areas of code. Every punctuation pair consists of an opening punctuation mark and a closing punctuation mark. The punctuation pair designates the area between them as having special meaning to the command that they are part of. The code written between the square brackets of the motor command indicate what motor the command should use. The code written between the parentheses of the wait1msec command tell it how many milliseconds to wait. Different commands make use of different punctuation. The motor command uses square brackets, and the wait1msec command uses parentheses. This is just the way the commands are set up, and you will have to remember to use the right punctuation with the right commands. Paired punctuation marks are always used together, and surround specific important parts of a statement to set them apart. Simple statements do the work in Robot C, but control structures do the thinking. These are pieces of code that control the flow of the program's commands, rather than issue direct orders to the robot. Simple statements can only run one after another in order, but control statements allow the program to choose the order that the statements are run. For instance, they may choose between two different groups of statements and only run one of them, or sometimes they might repeat a group of statements over and over. One important structure is task main. Every Robot C program includes a special section called task main. This control structure determines what code the robot will run as part of the main program. The left and right curly braces belong to the task main structure. They surround the commands which will be run in the program. When run, the program starts at task main's opening brace and ends at its closing brace. Task main is a control structure used to determine which lines of code are run by the program. In later lessons, you will learn about other control structures which are used to control the flow of statements. Remember that programming languages are meant to be readable by both humans and machines. Sometimes, the programmer needs to leave a note for human readers to help understand what the code is doing. For this, Robot C allows comments to be made. Comments are text that the computer will ignore. A comment can therefore contain notes, messages, and symbols that may help the human, but would be meaningless to the computer. Robot C will simply skip over them. Comments can be done in two ways. If you type // at the start of a line, the rest of the line will be considered a comment. Or, if you type /*, then any text up until the symbol */ will be considered a comment. These are some of the primary features of the Robot C language. Code is entered as text, which builds statements. Statements are used to issue commands to the robots. Control structures decide which statements to run at what times. Punctuation, both single-like semicolons and paired-like parentheses, are used to set apart important parts of commands. A number of features in Robot C code are designed to help the human rather than the computer. Comments let programmers leave notes for themselves and others, and whitespace helps to keep your code organized and readable.